Okay, so graph g of x equals cube root of 2 minus x. Solution, domain of g is negative infinity to infinity. Why? Because it's a cube root of a polynomial, actually a binomial, right? And so there's no restrictions on anything, so you get all real numbers as the domain. Since the index 3, that's because the index 3 is odd. So the vertex is where the radicand, or the argument, is 0. That is when 2 minus x equals 0, and that's when x equals 2, or 2 equals x, same thing. And that's important. It's always important to know where the vertex is. So graph 2 points to either side of the vertex, choosing values of x so that you get perfect cubes in the radicand. So 2 minus x is a perfect cube. Why do you do that? Because you're going to take the cube root of it, and it's a lot easier to graph if you end up with the cube root being an integer. So I just planned this out in advance. So I already have, when x is 2, 2 minus x is 0. The cube root of x is 0. So I already have the 0 when the 2 minus x is 0. So I'm going to use 1, because the cube root of 1 is 1. On the other side of 0, I'd have negative 1, right? And then I would have 2 cubed. Negative 1 is negative 1 cubed, right? Then 2 cubed is 8, and negative 2 cubed is minus 8. All right, so I'm just going on either side of the vertex, which is at 0. I'm sorry, which is when 2 minus x equals 0, always. Whenever the radicand is 0, that's the vertex. So I solved these. What I did here is I added the x to both sides, or just moved this over here, made it positive. Move this over to the left, this term to the left, it becomes minus 1. 2 minus 1 is minus 1. Hopefully you're getting accustomed to that. It's pretty easy. X goes over there, that goes over there, becomes plus 1. 2 plus 1 is 3. Right, same thing. X goes to the right. This becomes x on the right. And then you subtract the 8, and you get 2 minus 8 is minus 6. X goes over here. This goes over to the left, becomes plus 8. 2 plus 8 is 10. So I want to use these values of x. So I just write out in a little table, just because it's convenient. 2, when I plug 2 in here, I get 0. I already did that. If I plug 1 in here, I get the cube root of 1, which is 1. If I plug 3, I'm just getting the numbers from here. If I plug in 3, I get cube root of negative 1, which is negative 1. Remember, the negative in a cube root just comes out of the cube root. Negative 6, I put that in here. I get 2 minus a negative 6, which is 2 plus 6, which is 8. Cube root of 8 is 2. Right? And then 10. I put 10 in here. I get 2 minus 10, which is negative 8. Cube root of negative 8 is negative 2. And then I just graph these points. So that's the vertex at 2, 0. And then 1, 1, this one, 1, 1. And then 3, minus 1, this one. Now, this is why you don't just graph 3 points with a cube root, because it looks like they're in a line, so people just graph a line. Look, it's a line. No, it's not a line. Okay, cube root function, a radical function doesn't give you a line. Okay, so this is negative 6, 2, this one here. And then finally 10, minus 2, which is this one over here, 10, minus 2, right? Now, the way this is shaped, right when it gets, the moment it hits this vertex, it's vertical. So it's not pointy. So it curves up, and then immediately it starts curving to the left. Okay? Looks a little bit like half of a parabola there. And the same thing this way, but the parabola is going the other way. It's not a parabola, but it's kind of parabolic-like. So it looks like that.